everyone and welcome to my channel. So what is today's question? Today's question says the molecule that has only one lone pair of electrons on xenon. So we have been given four options and we have to find out that which of these molecules have only one lone pair on the xenon atom. And obviously the xenon is the central atom in all of these four options. So let's check these one by one. How we will solve this problem? So this problem will be solved by applying VSEPR theory. And how we apply the VSEPR theory in all of these molecules, that we have discussed many times in my previous videos. If you go back and check, we have solved many problems based on the VSEPR theory, where first of all we find out the total number of electron pairs in that molecule, okay, and then we find out the number of bond pairs and then the number of lone pairs. This number of lone pairs is the one that we have to find out in this question for each of these molecules, okay. Xenon is the central atom in all of these molecules. So how many number of valence electrons xenon has? So it is the general valence electronic configuration for xenon, that is a noble gas, is NS2 and P6. That means outermost how many electrons? We have 8 electrons, 8 valence electrons for xenon. Okay, so 8 valence electrons, that means 8. Okay, then how many atoms are sharing electrons, the neighboring atoms? So we have 2 fluorine atoms, so 1 electron each will be shared. So we will add 8 plus 2 and then we will divide this by 2 to get the number of electron pairs. Okay, we are calculating the number of electron pairs. Okay, so we have 5 electron pairs, right? And then how many bond pairs we have? Now in this XeF2, we have 2 fluorine atoms bonded to xenon, so 2 bond pairs. And how many lone pairs we have? So lone pairs we calculate by subtracting the total number of electron pairs minus the number of bond pairs. So we have 3 lone pairs in XeF2 in xenon. So xenon has 3 lone pairs in option A. Okay, we need only 1 lone pair. So option A possibility is eliminated. So this is not our answer. Then moving on to option B, XeF4. Calculate the total number of electron pairs. Xenon, the central atom, has 8 valence electrons and we have 4 fluorine atoms bonded. So 8 plus 4 divided by 2. So we have 6 electron pairs in total for XeF4. Number of bond pairs, we can see there are 4 fluorine atoms which are bonded to xenon. So 4 bond pairs, and the number of lone pairs will be 6. That is the total number of electron pairs minus bond pairs. 4 bond pairs we have. So 6 minus 4, that is equal to 8. So in XeF4, the number of lone pairs on xenon is 2. Okay. So option B is also eliminated because we need only that molecule which has 1 lone pair, which shows 1 lone pair on xenon. Okay. Now coming to option C, XeO2F2. Now we have an oxygen here. We have 2 oxygen atoms here, and in my previous videos, if you check regarding the VSEPR theory and different shapes of molecules, so we discussed that whenever we have an oxygen, there is a possibility of a double bond, okay, and VSEPR theory is mainly based on the sigma bonds, not the double bonds. So we ignore that contribution which is coming from the double bonded atom while we calculate the total number of electron pairs. So for total number of electron pairs in XeO2F2, we have 8 for xenon. Then neighboring atom, we have 2 fluorine atoms, each contributing 1 electron, plus we do not consider the contribution of oxygen because it's doubly bonded here, and then divided by 2. So we have 5 electron pairs in XeO2F2. So this kind of situation where we have a doubly bonded oxygen and we do not consider it while calculating the total number of electron pairs, that I have discussed in my previous videos. So you can just check those. And now coming to the number of bond pairs. So in bond pairs, we have 2 fluorine atoms bonded to xenon. Plus, here we consider the contribution of the bonded pairs because although oxygen is double bonded, out of the 2 bonds, we have 1 sigma bond contribution as well. So we consider the sigma bond contribution of that oxygen. So 2 oxygens, so 2 sigma bonded contribution. So number of bond pairs is 2 for oxygen and 2 for fluorine. So we have 4 bond pairs. Fine. And then the number of lone pairs. Number of lone pairs, we subtract 5. Total number of electron pairs is 5 minus number of bond pairs, that is 4. 5 minus 4, that is equal to 1. In XeO2F2, we have the number of lone pairs on xenon equal to 1. Okay, now let's check option D as well. So option D also we follow the same process. Valence electrons on xenon is 8. We do not consider the contribution from 3 oxygen atoms because of the possibility of a double bond. Then 2 fluorine atoms, 2 electron contribution through 2 fluorine atoms, then divide by 2, so 5 electron pairs. Number of bond pairs, 2 fluorine atoms bonded to xenon, and then we consider the sigma bond contribution of these 3 oxygen atoms. So 2 plus 3 is 5 bond pairs. Number of lone pairs, 5 minus 5, that is equal to 0. So in option D, XeO3F2, the number of lone pairs is 0. So the molecule that has only one lone pair of electrons on xenon is XeO2F2, because here we have the number of lone pairs equal to 1. So this is our correct answer. So option C, XeO2F2 will be our correct answer, where xenon has only one lone pair. So I hope this explanation was clear to you. And if you like my videos, please do not forget to like, share and subscribe. Till then, keep learning, keep watching, and see you soon with the next problem.